Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to continue the discussion on wireless connectivity. Okay, on the part 2 series discussion, okay, I have discussed how can we actually classify connectivity based on range and transmission power, data rate, and also bandwidth. This video, I will concentrate how can we actually classify connectivity based on the different form of security and also latency. Okay, so these two are also very important. Okay, I guess you know that nowadays, because of a lot of privacy issue, security of data become very essential. Next will be latency. Latency is actually means delay to send the information. For example, now when we actually communicate through the mobile phone, imagine the latency is in terms of minute. For example, now when I say hello, after 10 minutes you receive the word hello, then you probably will give up this form of communication. So therefore, latency is also very crucial when we actually classify connectivity. This will be the part 3 series discussion on connectivity. So guys, if you're keen to know more about wireless connectivity, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on connectivity. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask me your question through the comment. Okay, before I continue, okay, I'd like to urge you guys to help me by like this video. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let's quickly discuss how can we actually classify connectivity based on security. Okay, wireless connectivity is also crucial. Okay, therefore we like to classify them based on their security capabilities. Okay, which are definitely to protect our data, our device, and network from unauthorized access, eavesdropping, and also cyber attack. Okay, the classification is based on the encryption method. Okay, and then the authentication mechanism, and also how vulnerable it will due to the security threat. So for security, there are actually four levels. First one will be low security wireless technology. Next will be medium security wireless technology, high security, and last but not least, very high security wireless technology, which is mainly used by military guys. Okay, so basically this is the so-called different tier of security. Let's go through them one by one. Let's start by discuss on the low security wireless technology. So the key feature is basically there is basic or even no encryption for this form of wireless communication. They have limited authentication protocol. So therefore, because of this, they are actually very vulnerable to eavesdropping, spoofing, and also interference. Some of the example of low security wireless technology will be infra. Okay, so infra is basically used by remote control. So therefore, in this form here, the security is actually very minimum. So what is the form of security? Is basically with the physical line of sight. Okay, which means that the transmitter can actually see the receiver. So for example, when you press your remote control, okay, so basically it's line of sight. So you actually ensure the data will be only intercept by the receiver. That's all. So basically, this is actually one of the low security, okay, for wireless communication. Okay, so the application, as I mentioned, will be remote control, okay, and then some legacy device, very old device here. So the risk is actually this form of data, they are very easily intercept, okay, if the line of sight is actually compromised. Okay, as for analog radio, okay, for FM and AM broadcast, simply there is no security, okay, because the broadcast is open, free for everyone to receive. So for this form here, like for example, the application will be traditional radio communication here. The risk, okay, again, it will be very vulnerable to signal jamming and interception. Okay, but I guess no one will really want to so-called jam up the FM or AM broadcast. Maybe for military purpose, then we will jam, but definitely not for FM and AM broadcast. So basically, these are the form of low security wireless technology. Next, let's move on to the medium security here. So let's come to the key feature first. So they have some form of basic encryption method and also some authentication. Okay, they are actually very resistant to common attack like eavesdropping and replay attacks. They may require additional layer of security for sensitive application. So this is medium. So therefore, if you need to send some sensitive, some crucial data, then you need to have some form of additional layer of security to support this wireless connectivity. Some of the example for this medium security wireless technology will be Bluetooth, both the classical and also the Bluetooth low energy. So the security is basically they use this secure simple pairing, okay, SSP. Okay, so I guess when you use this Bluetooth for the first time, you are required to do pairing. So basically this is one form of security and also the AES 128 encryption. Okay, so the application, okay, will be all those wireless preference and also IoT device. The risk, okay, again, because it's medium, so it also will be quite sensitive, okay, and may be very vulnerable to attack like blue jacking, blue snuffing, and relay attack, okay, if it is not properly secure. Next, we like to go to Wi-Fi, okay, WEP, wire equivalent privacy, and WPA, Wi-Fi protected access. Okay, so in this form here, the security is we have some form of basic security. Okay, so for example, for WEP, wire equivalent privacy. Okay, so this is a very old technology, and therefore it will be quite still highly vulnerable to be hacked. Okay, as for application, okay, so basically it will be the legacy Wi-Fi network, which means that the very early days of Wi-Fi network, okay, which don't exist in current world now, I believe. As for the risk, okay, again, it will be very vulnerable to key cracking and also eavesdropping. Okay, so basically this is for medium security wireless technology. Okay, let's move on to the high secure wireless technology. Okay, so as for the key feature, we are going to have advanced encryption standard and also very strong authentication protocol. Okay, because we are so-called we mentioned about high secure, so they are definitely very resistant to threat like brute force, replay, and man-in-the-middle attacks here. So they are better protected against any so-called hacking, etc. So there will be a regular updates and also patch to address vulnerabilities. Okay, so once they know that there are some form of vulnerability, okay, they will have some regular updates, just like our window. Okay, we have regular update, we have various patch to address any vulnerable. Okay, so basically this is for high security wireless technology. Okay, so under high security, we have this Wi-Fi. Okay, so this WPA, okay, Wi-Fi Protect Access 2 and Wi-Fi Protect Access 3. Okay, so for Wi-Fi Protect Access 2, they are actually using AES 128 encryption. Okay, so basically they are strong, but again, they will be very vulnerable to some form of attacks. As for WPA3, okay, this is actually a enhanced encryption. So basically they consist of 192 bits in encryption model. Okay, this will actually mitigate the brutal force attack. Okay, so as for application, okay, so our home Wi-Fi and some of the smaller enterprise network and also IoT, the risk, okay, when we actually use this Wi-Fi Protect Access tool, which is the older version, they can be actually compromised, okay, if default password or weak key are actually used. Okay, so basically people can enter through the so-called default password or maybe some weak key, which means that some not strong password. Okay, when they actually use it, may be have the vulnerable to be hacked. So for Zippy here, Zippy is also using the AES 128 encryption. Okay, so basically they have this device level of authentication. Okay, which means that the device actually will seek the authentication to the Zippy coordinator. Okay, so if you can, okay, look at the Zippy video to understand more. As for the application, Zippy is widely used in smart home and some of the IoT network. Okay, as for the risk for Zippy, they are actually very vulnerable to over-the-air extraction if they are not properly secure. Okay, and the last one on the high secure wireless connectivity will be the cellular network, which we are very comfortable 4G, 5G. Okay, so basically the security is end-to-end encryption. They have a mutual authentication also, 256. Okay, so AES 256 encryption in 5G. Application will be mobile broadband. Okay, so basically our mobile, okay, which communicate with the base station, IoT, and the form of data that we actually send will be voice or data. The risk, okay, the location tracking, okay, so basically the location, they will be able to track our location, and they may also be able to jam, okay, although it's very rare. Okay, in fact, it doesn't really exist, but I think in terms of tracking our location, okay, some of the so-called middleware actually will be able to track this. Let's move on to the last one in terms of security. Okay, under very high security. Okay, so the key feature is this form here is actually a military grade encryption. Okay, which means that they will not compromise anything. So everything they will definitely encrypt all the protection, etc. So they have multi-factor authentication and also the tamper resistant. This form here, they are actually minimum vulnerability, okay, so to eavesdropping and also attack. So these are designed for highly sensitive application. Okay, for example, for 5G, okay, we have this advanced security feature. So they have a strong encryption, and they also have this enhanced authentication protocol that is actually protect against signaling storm. As for application, they have critical infrastructure, okay, and autonomous vehicle. Okay, so these are mainly use 5G, okay, for critical infrastructure and autonomous vehicle. So nowadays there are more and more autonomous vehicle that using the wireless connectivity of 5G. The risk, okay, they are actually very potential for sophisticated and also state-sponsored cyber attack. Okay, from time to time, you actually can see that the countries actually mentioned that there are some form of state-sponsored cyber attack. Okay, so basically this is the meaning here. Satellite communication, okay, so basically for military, they will be encrypted. Okay, so basically for security, customized encryption protocol, and they also have anti-jamming measure. Application, okay, for defense, secure government communication. Okay, so basically they have important message communicate between government, so therefore they need to have this form of highly secure, very high secure wireless connectivity here. The risk, definitely anything with high secure, there is a price to pay, which is expensive to implement. And they may be still quite vulnerable to signal spoofing. Ultra wideband, okay, is another example of very high security wireless technology. Okay, because of the wideband, it's actually very difficult to so-called intercept the UWB signal. So secure, they are very high resistant to interference and eavesdropping, okay, due to the short pulse. Short pulse is because of high bandwidth, therefore they have short pulse duration and also wide frequency range. As for application, okay, they actually can secure position. So basically UWB nowadays are used mainly to do asset tracking. So therefore they also able to do some prediction system mandatory purpose here. As for the risk, okay, they require precision implementation to ensure security. Okay, so next, a quick table to summarize what I have discussed under low, medium, high, and very high security here. And you can see the technology and all the feature. Okay, so I won't go through one by one. Okay, so before I continue, okay, on this here, like to urge you guys to help this channel by like this video and subscribe if you have learned something from this video. Okay, so let's continue in terms of latency. Okay, so wireless connectivity can also be classified based on latency, okay, which refer to the time it takes for the data to travel from the source to the destination. Low latency is critical for real-time application like gaming, video conferencing, autonomous vehicle, and also industrial automation here. Below is a detailed classification of wireless technology that is based on their latency. As I mentioned earlier on, latency is the delay. Okay, so basically these are the delay for the round trip communication here. How much will be the delay? How much will be the latency? So under this latency, we have four category. Ultra low latency, which means that almost no latency, almost live data. Low latency wireless technology, medium latency, high latency wireless technology. Okay, let's take a look on the ultra low latency wireless technology. Okay, so basically latency typically is less than 1 millisecond. You can't even detect 1 millisecond. So basically for this case here, it's typically less than 1 millisecond. So the key feature is mainly to design for real-time delay sensitive application. It requires advanced infrastructure and also include edge computing and also low latency protocol. So one of the example for ultra low latency is the 5G. 5G actually has three box to fulfill. They have one of the three box is actually under this ultra reliable low latency communication, which is called URLLC. You can see the key emphasis here is on low latency. So the latency is around 1 millisecond. Application autonomous vehicle. So autonomous vehicle need to have low latency. Just imagine when you come into the junction, whether you want to turn left, turn right, or continue. So imagine you stop at 1 second. It's not acceptable. So therefore, the latency need to be as small as 1 millisecond. Same for robotic surgeon and also some of the industry IoT application here. Key feature, high reliability and low delay for mission critical tasks. So basically this is the example for ultra low. So basically we need to ensure high reliability of data, and we also need to ensure low delay for anything that is mission critical like autonomous vehicle. So another example of ultra low latency will be UWB. So UWB can even better getting the latency of 0.1 millisecond. So the application is basically real-time location system. So basically I told you earlier on, UWB nowadays is also used to do asset tracking or even track some of the so-called personnel, etc. So therefore we have this form of real-time. So the delay is very, very small. And for for AR purpose also, so the feature is they are actually very extreme low latency, and we have precision location tracking. So let's move on to low latency. So the latency start to increase a little bit. However, I will say that it almost very difficult also to detect 10 millisecond. So basically this is for low latency here. The key feature is to support interactive application like our game. When we play game, we do not want to have any latency, and also for video conferencing. So they actually balance the latency with other factors such as the range and also the data rate. So basically because of the range, we need to send a longer range. For example, the signal need to travel further away, so therefore the latency technically will be increased with a longer range. Same for data rate. So basically if you have more data, then you will have a longer latency to send the data, etc. So one of the key example, for low latency will be the current Wi-Fi standard that we are actually using. So maybe now some of you guys actually use Wi-Fi 7, but I think majority still fall under this Wi-Fi 6 or 6E, 6 as standard. So which is the 802.11ax standard. So basically you can see that the latency for Wi-Fi 6 is actually maximum, maybe up to 10 millisecond. So the key thing, basically we play games using Wi-Fi online game, which guarantee low latency video streaming and those virtual meeting here. So which is what I have discussed also. The key feature is basically they make use of this OFDMA, to reduce congestion and also latency. I have discussed how we actually can use this OFDMA to reduce congestion and latency at the Wi-Fi series. Again, if you can, please take a look on the Wi-Fi series discussion. Let's move on to the another example for low latency, which is the 4G, which is the LTE. So the latency is around 10 millisecond. So this need to be considered under this optimum condition. For application here is basically for video call, mobile internet. Feature will be moderate latency, sufficient for most consumer application. So they have some latency, but we still can wait. So basically, for example, we serve some information on the internet, we still can wait. So therefore, this type here, we just need to have low latency wireless technology. Next, on medium latency wireless technology, so the latency actually increase, from 10 for the low latency to medium is actually up to 100 millisecond here. So for the key feature is basically they are suitable for less time sensitivity application. For example, when we actually transfer a file, or non-real-time IoT application. For example, we send our temperature, our humidity. Okay, so basically we don't need to have real time. So basically this is the fall under this medium latency wireless technology, can suffer from delay due to congestion, interference, or processing overhead. So basically, these are the key feature for medium latency wireless technology. Some of the example, okay, so again, two form of Bluetooth, the classical one and also the Bluetooth low energy fall under this medium latency. Okay, so the latency can be up to 40 millisecond for the classical one. For Bluetooth Low Energy, the latency can even slightly more, which is 50 millisecond. So for the application, audio streaming is for the classical one. Fitness tracker will be from the BLE, same as for the wearable are from the BLE. So the feature, they are actually optimized for low power and moderate responsive. Okay, so basically you don't need to send a lot of data. Even you send the data, you can accept some form of delay. Okay, so some of the Wi-Fi, older Wi-Fi standard, okay, fall under this medium latency. The latency for this older Wi-Fi will be up to 100 millisecond. So again, in the old days, we still browse the internet, we still doing some file sharing, medium streaming. Okay, but you realize that the delay is actually longer. Okay, so the feature is higher latency compared to the newer Wi-Fi standard, especially under load, okay, which means that when there are more user, okay, the latency also will be increased. Let's move on to the high latency. Okay, high latency, which means that there's a lot of delay wireless technology. So the latency increased to more than 100 millisecond. Key feature, okay, you are going to have a long delay. Okay, make this technology unsuitable for interactive or real-time tasks. Basically, the latency is so much that you don't want to do any interactive or even real-time tasks here. So they are often optimized for long-range communication or low power consumption. Okay, for example, LoRa, okay, is under this high latency wireless technology. Okay, so the latency you can see that it can be as high as 500 millisecond. However, okay, the key application is we are going to have low power and also long range. Okay, this is actually the essential feature of LPWAN, okay, which LoRa is part of LPWAN. So the application, we can do some environment monitoring, smart agriculture, etc. So the key feature is basically they prioritize, the key thing is how we can remain low power efficiency, okay, over the speed and also the responsiveness. So basically anything that is crucial, crucial, then you don't put it under LoRa, because LoRa actually has high latency wireless technology. Satellite communication, yeah, they are so far away, so therefore the latency you cannot expect that they will be low. So for satellite communication, okay, the latency can be even up to 1 second, okay, for the geostation satellite. So the key application again, okay, we are able to some form of remote internet, and this satellite communication also allow us to have global communication. Okay, so the feature, okay, we are going to have high latency, okay, due to the signal travel distance. The signal is so far away, or sorry, the satellite is so far away, which is 36 kilometer away. So therefore, you are anticipate the high latency for this form of so-called communication, satellite communication. Okay, so I put everything under one table here. Okay, so basically you can see that the latency, okay, from very ultra low latency all the way to high latency, which means that high delay. Okay, so with this, I'd like to end my discussion. Okay, please up to like and subscribe. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you.